5.8, quadratic formula. So the quadratic formula is pretty much the go-to surefire way to get the most accurate roots for your quadratic. And so we've showed you many methods of how to solve a quadratic and find where it's crossing the x-axis. You can graph it, you can factor it, you can complete the square, you can use the quadratic formula. These are all great strategies, and some lend themselves very easily to one strategy more than the other, but the quadratic formula is the go-to in any situation, will always work for you strategy. So this is the one that you definitely want to know how to do above and beyond all the others. You're going to have to commit the quadratic formula to memory. It is x equals, so x equals, this is how we're going to find those x-intercepts. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. That's all under the radical, all over 2 times a. And so this strategy is simply plug and chug. Where do you think a, b, and c come from? They come directly from your quadratic, whatever it is. Remember, your values of a, b, and c are the coefficients in front of the quadratic term, that's your a, the coefficient in front of your linear term, that's your b, and then the constant at the end. And so you just take those numbers directly out of your quadratic, you plug them into that formula, and then you solve for the answer. So it's a plug and chug kind of strategy. The discriminant tells us, gives us a little hint as to what our answer should look like before we actually calculate it all out. And that's always good to know. It gives us a little hint, lets us know if we're on the right track. The discriminant of the quadratic formula is the section of it that is directly under the radical. So the discriminant is b squared minus 4 times a times c. Not the radical part, just the number you get under the radical. The value of the discriminant tells us the type and the number of solutions that we're going to get. Okay, so let me scroll the page up, and we're going to talk about how the discriminant is going to help us. So the value of the discriminant. So if the value of b squared minus 4ac, if what I get when I plug those numbers in under the radical are greater than 0, okay, then that means that your answers are going to be 2 real solutions. 2 real solutions. And that might look like a radical or a quadratic that crosses like this, where you get 2 real, very obvious solutions. You can graph them, 2 x-intercepts. Okay? Remember, your quadratic could also be heading downward. Maybe it's going this way. And these are your 2 points. It doesn't always have to be part on the left or part on the right of the y-axis. It can be anywhere on the x. So it's all the way across left or right, up or down, but you have 2 significant spots where it crosses. b squared minus 4ac equals 0. So now the number underneath the radical is equal to 0. That is telling you that you're going to have 1 real root. So if the parabola is only crossing at one spot, that one spot has to be the vertex of the parabola. Okay? So it could be an example that looks like that. Maybe the parabola is going this way, up or down, but the idea is that it's the vertex. So the vertex equals the x-intercept in this case. Okay? And then your last example. So we have parabolas that cross at 2 places. We have parabolas that cross at one spot. Can we have a parabola that crosses at 3 places? No. But we could have a parabola that crosses at no places. b squared minus 4ac is less than 0. If that amount under the radical is less than 0, then I'm going to get a negative root. Right? I'm going to have a negative root, some negative value under the root, and that's going to give me 2 imaginary solutions. And so I have a parabola that doesn't cross the x-axis at all. It's kind of hovering up here, or it's kind of hovering like this. Oh, sorry, that would cross, wouldn't it? I meant to put it down here. Or it's going to be hovering down here. And so you say to yourself, well, you're getting two answers, so that's leading you to think that it's going to cross the x at two different places. But what you need to realize is that this is in the imaginary number system. So you have this parabola that's kind of hanging out in three-dimensional space. If you think about your top quadrant like a cube, quadrant 1 is like a cube, that parabola is kind of hanging out there in three-dimensional space, kind of just like a big bowl of jello. It's kind of like embedded in the middle of the jello, just kind of hanging out there. It's not down below the x. It's not intercepting the x. It's just kind of hanging out in quadrant 1 above the x-axis. And that's really all that we can explain to you at this point without going into further detail. When you hit some upper level math classes and you really start using things in the imaginary number system, this will become a lot clearer to you. So what you need to know right now is your options are, you have a clear parabola in a two-dimensional system that crosses the x-axis in two places with the first example. You have a two-dimensional parabola that's crossing at one place. The vertex is on the x-axis in example 2. And then in example 3, it's really not two-dimensional. It's really moving into a different dimension. It's moving into a different set of numbers. And you just need to know that it's not at this point crossing the x-axis at all. Okay? So those are going to be your three choices. So let's talk about this. I'm going to scroll the page up, and you're going to move on to the next page. And we're going to actually practice one. Okay? So use the quadratic formula to identify the number and types of solutions and then solve. So first we have to write it in standard form because the 2 is on the wrong side of the equation. So let's move it over. 3x squared minus 5x minus 2 equals 0. Your first job is to identify a is 3, b is negative 5, and c is negative 2. Write the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to substitute into our equation. Okay? The opposite of b. So the opposite of negative 5 plus or minus the square root of negative 5 squared. You need to be so very careful about your signs right here. It's negative 5 times negative 5. That should always be a positive value. Minus 4 times a, 3, times c, negative 2. And remember, that's all under the radical. All over 2 times a. And now it's just a matter of simplifying. X equals the opposite of negative 5 is 5 plus or minus square root of negative 5 times negative 5 is positive 25. And then I have negative 4 times 3, that's negative 12. And then negative 12 times negative 2 gives me positive 24. All over 6. Let's combine together what's under our radical. X equals 5 plus or minus the square root of 49 all over 6. So let's think about what kind of roots we're going to have. 49 is our discriminant. That's our b squared minus 4ac, and that's greater than 0. So if you go back to your chart, greater than 0 means two real solutions. Okay. So if I know I'm going to have two real solutions, I better be able to come up with two numerical values. And there should not be any i's in my problem. Those are complex solutions, right? And I should have two answers. So what's the square root of 49? 7. So 5 plus or minus 7 over 6. Again, there are two roots here. There's 5 plus 7 over 6, and there's 5 minus 7 over 6. Two roots. 5 plus 7 is 12. 12 divided by 6 is 2. 5 minus 7 is negative 2. And over 6 equals negative 1/3. So your solution is negative 1/3 and 2. Those are your roots. So this is just a matter of plugging it in and solving for the answer. So I want you to go ahead and try numbers 1 and 2, and you can check with the teacher afterward to see how you did on those two questions.